Hello dear students, welcome back to my channel. I hope I am audible and visible to all of you. Am I audible and visible? Hello dear students, welcome back to my channel. I am audible. Okay, so as you know that we are discussing AC now, this A and C alternating current, right? And today we will be discussing lecture number 4. So this chapter will take maximum of 5 lectures. That means today we will be discussing second last lecture of AC. Okay. So in previous lecture we discussed about LCR circuits, and in LCR circuits we discussed the first case where my VL, the potential across the inductor or the capacitor, is more than the different one. Okay, because VL is more than VC or XL is more than XC. Okay, we discussed that case. We discussed the phasor diagram, that thing also, right? So let us continue now the series. Okay, so then we discussed about RL series, RL combination and RC combination. And in RL combination, the impedance means the net resistance given by the circuit is R square plus XL square, or in XL it is omega times L also. Okay. Now, in today's lecture, we will continue our from the particular point. So let us start second last lecture, lecture number 4. Lecture number 4. In lecture number 4, what we know that the V naught, that is peak value of input, equals to I naught current multiplied by the resistance Z. So we got this equation from Ohm's law, that is V equals to I times R. But here we replace the Z, R with the Z. So how to write now I naught? Sir, I naught, I can write I naught as V naught by Z. V naught, what is Z? If we are having a system, so I can write R square plus XL minus XC whole square. It is not compulsory, it is XL minus XC, so it could be XC minus XL also. There is no difference between, look, XL minus XC root, it is equals to XC minus XL root. There is no difference between these two terms. Okay, because we are having squaring now, so in squaring we don't consider these things then. Okay, okay, so my aim is, so what is our aim? If I need to write here aim, my aim is to maximize current. My aim is to maximize current. So I can write I naught needs to be maximum. I naught needs to maximum, or you can write the impedance should be minimum. Impedance should be minimum. If these things occur, so we can write my circuit has a maximum current or minimum opposition. Okay, so for this particular line Z to be minimum, so what we can write? We can write that if my XL, inductors reactance, if it is equals to my capacitor reactance, so therefore what will be my Z? Z came out to be R square plus 0 square root, which is equals to R only. Which is equals to R only. I guess this term implies that whenever my system whenever my system where my XL is equals to XC. So in this particular scenario, my current will be maximum, my opposition will be minimum, and the opposition will be equals to the resistance only. Done now? Okay, sir. So now let us just elaborate this thing now. What is XL? XL is equals to omega times L, and XC means 1 divided by omega times C. So I can write omega square is equals to 1 divided by LC. So my omega is equals to 1 divided by under root of LC. 1 divided by under root of LC. And this particular frequency omega, this particular omega, so this particular omega is known as resonant frequency. So I can write here this frequency known as resonant frequency. Resonant frequency. Or, okay, here I can write or. Sir, what is or now? So one thing that you know that, what is omega? Omega is 2 pi f. 2 pi f equals to 1 divided by under root of LC. So f came out to be 1 divided by 2 pi under root of LC. Second formula is here now. So we are having two formulas to calculate my resonant frequency. This is also my resonant frequency. This one is also my resonant frequency. Resonant frequency means when the frequency of my particular electrical component. Resonant frequency means at this is that particular frequency at which the incoming AC frequency is matching the frequency of my electrical equipment. Okay, so look, we are having equipments. We are having my L inductor, we are having C capacitor, both having their own frequencies, no, inbuilt frequencies. Okay, when we are providing some input, whenever we are providing some input, if the input frequency matches the frequency of my electrical equipment, at that particular moment we can call it as a resonant frequency. Okay, you have seen now, look, in many videos on the YouTube, you have seen whenever a particular person is holding a glass na, in front of the person, and the person shouts towards the glass, after some time the glass break down. Do you know why? Look now, we know that the particles of glass, they are in vibration, they have their own natural vibration of material. Yes, when a person is throwing the voice with some frequency, when the frequency of the person matches with the frequency of the glass particles, so this is a resonant condition. At this particular condition, the output will be maximum, so current will be maximum, and the resistance is the minimum. Sir, we are having two formulas. So how we can just say that at what particular equation we can use one formula, and what particular equation we can use second formula? If something is given in a radian per second, if something is given in a radian per second, that is omega. If in hertz or cycle per second, we can use the frequency f. Easy na? So in today's lecture, I just improvise my handwriting. I'm just writing in a very slow manner. Okay, I thought that you can take a maximum notes now from my class. I guess up to this point now everything is clear, right? Is everything clear up to this particular point? If yes, then you can let me know. Okay, look now. So if you are having everything good and very clear to you now, one thing that I want to show you now. That thing is, look now. If we recall the yesterday's lecture, if we recall the yesterday's lecture, we know one thing that, look, one thing that we know, that is my reference line. Okay, one line. One more line. Okay, so we know this particular line is I naught, and also this one is known as VR. This one is known as VL. This one is VC. This one is V naught. So if VL is equals to VC, so I can write here my VL equals to VC. What is VL? Sir, it is I times XC. What is VC? Is it I times XL and XC? One second. This one is XL. This one is XC. Now we can cancel out this I with this I. Now, so XL is equals to XC. XL is omega times L and XC is 1 divided by omega times C. I will write omega square is equals to 1 divided by LC. So I can write omega is equals to 1 divided by under root of LC. Or I can write F equals to 1 divided by 2 pi under root of LC. So it simply implies under the resonant conditions, the potential across L is potential across C same. Resistance of L equals to resistance of C, and omega equals to 1 divided by root of LC, and F equals to 1 divided by 2 pi under root of LC. So these are my conditions for my LC. Now, if you want to check the phase, this phase, no? If you want to check this phase, so we know one triangle now. I guess you all are very aware of the impedance triangle. Okay, so this is my impedance triangle. This is my theta. This is my Z, R, XL minus XC. This triangle is known as impedance triangle. Impedance triangle. What is tan phi? Tan phi. Is it P by B? What is P? Is it XL minus XC divided by B is R? XL is equals to XC, it is 0 by R. So therefore you can write tan phi equals to 0. Therefore phi equals to 0. So no phase difference. No phase difference. So we don't have any phase difference now. In this condition, we don't have any phase difference. I guess you are well aware of these things, right? Done now? Easy or super easy? Easy or super easy? And I need a 1 more minute from your end so that I will give you some numerical things, right? Give me 1 minute. 1 second. 1 second. My network is slow now, but still easy, right? Mm-hmm. So I am gathering some numericals. One second, beta. I'm just getting some numericals from your revision purpose. Okay. Now, is my screen visible to you? यादव GSP 0007 बेटा हमने क्लास कब की स्टार्ट कर ली? Okay, now first numerical on the screen now. First numerical on the screen now. Okay, and numerical is like, you can just read this numerical, and the numerical is like impedance of the circuit shown in the figure is. So we have to find impedance. To find impedance, first thing what we have to find out, sir, Z. Impedance is equals to R square plus XL minus XC square the root. Okay, but here we don't have any capacitor term, so there is no fun of writing XC. No fun of writing XC, so I can write XL square. What is R now? R is, we don't have any R, right? No. So there should be some look now. So that I can use V equals to IR now. V equals to IR. I need to get my R, or instead of R, I will write Z, my impedance, Z. So we don't have any V now, but I is 3. So I can write V equals to, or V divided by 3 equals to Z. How to find out V? We know that V equals to, is it V R square plus VL square root. VR is 190, it is 90 square. VL is 120 square root. 9 9 is 81, so we are having 8100. 120 120, it is 144. 144 and 00 a root. Okay, it is 0 0 5 2 2. It is 22500, which came out to be 150 volts. So I can write Z equals to 150 divided by 3, it equals to 50 ohm. 50 ohm. So my answer is 50 ohm. Option number second. Okay, you can take the screenshot of this numerical also. You can practice at your place. Okay, second numerical. Second numerical. Second numerical. Numerical like in a circuit shown in the figure. Okay, done. In the figure. Okay. So the voltmeter and the ammeter readings will be. So we have to find out what the voltmeter will read and what the ammeter will read. Look now. Voltmeter is across L and C. So voltmeter will read the potential difference. Voltmeter will read potential difference across inductor and capacitor. So it will write VL minus VC equals to V. What is VL? Look, it is 25 ohm, 25 ohm. If both are at 25 ohm, so we can guess that both are, these are at resonance, right? Resonance. If it is a resonance, so we know the second condition for resonance, which is VL equals to VC. So V came out to be 0. So the reading of V will be 0. So this could be answer possibly, and this could be possibly answer. Now I need to get my I. I need to get my I. Okay. So what is V? Sir, V equals to I times Z. We know it. Okay. What is V? V is 240. I we don't know, and Z we don't know. Done. So look now. If it is a resonance condition, so my Z equals to R only. So I can write 240 divided by Z. Z is 30. 30 equals to I. I cancel, 0 cancel out, so I came out to be 3 on the 3, 8 it is 8 ampere. Option number 4 is my correct answer. Option number 4 is my correct answer. Okay, now this one now. This one numerical now. This numerical states that in the circuit shown below, the current measured by the ammeter is. So we have to measure the current through this ammeter. No worries. So look, what we can know now. Look, if current I will flow through this one and I will flow through this one. What is Ohm's law here? Sir, V equals to IR. We have to find out I, but for that we have to find out V. So my I equals to V by R. V is V, I is 10. So we have to find out V. We have to find out V. So what is V now? Sir, I guess V equals to, it is VR square plus VL minus VC whole square root. What is VR square? VR is, it is, we don't have any 10, no? It is V. What is V? V is 50. It is 50 square. VR square as it is VR square plus VL is 60. It is 60 minus 100 or 100 minus 60, no issue. It is 2500 equals to V square R. It is 40. 40 plus 40 is 1600. So my V square R came out to be 900. So V came out to be 30. 30. So now Vi equals to 30 by 10. So it is 3 ampere. 3 ampere. 3 ampere only. Easy? Easy or super easy? Easy or super easy? Easy now? Okay. This one now. Numerical like, what is the voltmeter, no, voltage applied in the following case? Okay. So first, what you will think now? You will think, sir, V is equals to VR plus VC plus VL. What is VR? Is it 60? 60. VC is 40. VL is 120. So you can write my answer came out to be 0, 0, 6, 4, 10, 10 to 12, 220 volts, right? So you can write this answer, right? I hope you will write this answer. So you will tick on this one, but it is incorrect. Incorrect. Do you know why? Look, You know that if we are talking about VR, there is no phase difference. If we are talking about VL, yes, voltage leads by 90 degree. If we are talking about VC, current leads by 90 degree. So we cannot use the ordinary algebraic thing. So how we can get this thing now? I will write V is equals to VR square plus VL minus VC whole square root. What is VR? Is it 60 square? Yes, sir, it is 60 square. VL is 120. It is 120 minus 40 square. Then we are having root 60, 60, 360, 0, 0. 140, 20 minus 40, it is 80. I guess 6400. Yes. Root 0, 0, 0, 0. 40. I guess it is 100 only. 100 volt. So my answer is 400 only. Easy. So this is not my answer. This one is my answer. Okay. Next numerical. Next numerical and next numerical. Next numerical. Look now. What is numerical? Numerical is like we have an ideal inductor with inductance 1 by pi Henry is connected series with 300 ohm resistor. So it implies that we are having inductor. So we are having inductor then resistor. Inductor, a resistor. Then at 20 volt 200 hertz AC source, 20 volt 200 hertz. The phase difference. So we have to find the phase difference or tan phi. Okay. Is it XL minus XC divided by R? So we don't have any XC, so it is XL. So my tan phi is equals to, is it XL by R? XL. What is XL here? Is it omega times L whole divided by R? Done, no? Okay. Tan phi. Omega is 2 pi F. 2 pi F. What is F? F is 200. L is 1 by pi Henry whole divided by R. R is how much? 300. 0, 0 cancel out. Pi cancel out. It is 4 divided by 3. So phi is equals to tan inverse 4 by 3. Tan inverse 4 by 3. This is my answer. Easy or super easy? Is this easy or super easy? Yes? Okay. Now look now. Next topic will be power in AC circuit. My next topic is power in AC circuit. Power in AC circuit. Look now. Resistor, inductor, capacitor. Joined series. Resistor R, XL, XC. Input equals to V naught sine omega t, and current is equals to I naught sine omega t plus phi. Na? Let it be any angle. We don't have any idea about it. Clear? Okay. So what is power? What is instantaneous power? Is it V times I? Yes, sir. What is V? V equals to V naught sine omega t. What is I? I is I naught sine omega t plus phi. After solving, you don't need to solve it. After solving, you will find the derivation in your NCERT also. After solving, your average power will be Vrms, Irms, then cos phi. You will get this equation at the final one. You will get this equation at the final one. Done. And this cos phi is known as power factor. This cos phi is known as power factor. Done. So one more time, let us just create impedance triangle. Z R XL minus XC. This is phi. What will be cos phi now? Cos phi B by H. What is base? Base is R. What is H? H is Z. Is it R by Z? Yes, it is R by Z. So can I write now P average here? Can I write now P average here V? What is V now? I said I can just write V equals to IR only, right? IR. So it is I into R. But instead of R, I will write Z, impedance, right? Z. Then this I, as it is IRMS, then cos phi. So P average equals to I square R ms Z into cos phi. Then Z into cos phi. So now can I write now P average equals to I square R ms into Z and cos phi. Cos phi is R by Z. Z cancel out. So my equation came out to be, is it I square RMS into R. These are my equations of my average power consumption in my LCR circuit. Power equals to, sorry, it is VI cos phi or I square into R only. You can write this thing down. Easy or super easy? Is this easy or super easy? I am NEET with Arman. Yes, beta, I can see your comments, right? I can see your live comments. Don't worry about it. Easy, no? I guess these are some very easy things that you can remember, right? So look now, the most interesting part here is that you need to remember, right? That is, look now. If we are talking about pure R circuit, pure R means in which only R is present. So what is phi angle? There is no phase difference. No phase difference. There is phi is 0. So what will be P average now? Sir, P average equals to VRMS then IRMS into cos phi. I will write cos 0 degree. So look now, P average equals to VRMS, IRMS, and cos 0 is 1 degree. So this is my power consumption by your resistor only. By your resistor. Now next part. If we are talking about pure L means in which only inductor is present. In inductor, phi equals to 90 degree. So can I write now P average? So P average is equals to VRMS, then IRMS, then cos 0 degree, no, 90 degree, and cos 90 is equals to 0. So my power and consumption is 0. So this thing you need to remember, the power consumption by your inductor is equals to 0. It doesn't consume any power. The third one, if we are talking about pure C, in pure C also phi equals to 0 and cos 0, sorry, cos 90, and cos 90 is 0. So I can write P average equals to VRMS, then IRMS, then cos 90, and cos 90 is 0. So my P average equals to 0. So it simply implies that no power consumption by your capacitor or by your inductor. No power consumption. Only power consumption is due to the resistor one. Only power consumption is due to the resistor one. Then now you can see power consumption is only due to the resistor one. If now I guess you have noted down up to this particular point now. Look now. Do you know one thing? If this particular line represents VRMS, if this line represents VRMS, and we know at some angle we are having IRMS. This one is my angle phi. If we apply vectors here, so we will be having one component along this one. So is it IRMS cos phi? Yes, sir. One component will be along perpendicular to it. Is it IRMS cos 90? Okay. So in previous case, we conclude one thing. When theta equals to 0, power consumption is there. When theta equals to 90 degree, no power consumption. So now this particular part, it doesn't contain any power consumptional thing, right? So this particular part, that is IRMS cos 90 degree, it doesn't contain any, it is not cos 90, sine component, right? You are not correcting me, right? It is sine theta now, sine phi. So this particular component doesn't contain any power thing. Now I can write here, I will write here, no power consumption. So due to this component, there is no power consumption. If now there is no power consumption, so this particular thing, that means IRMS sine phi, this particular component is known as wattless current. So what is wattless current? So wattless current is that component of your IRMS which doesn't dissipate any power, which doesn't contain any power. Wattless current. Clear? So we had done with the wattless things also. So if you need to remember the sine one, so we know the impedance triangle, right? Very well. We know the triangle very well. So this triangle is all about, it is phi z or xl minus xc. So you can write sine phi p by h. P is xl minus xc, hz. This thing you need to remember. Done? Easy or super easy? Is this easy or super easy? Okay, you don't need to remember maximum definitions. Now, I am making these things very easy to just get these things in your mind, right? Easy or super easy? Huh? Okay, now let me just grab some more numericals. For you. We grab. 1 second. One second. Okay. Okay, now let us discuss now more numericals. Okay. Okay. This numerical states that the net impedance of the circuit will be. So we have to find out net impedance. So what is the formula for net impedance? I guess you know it now. So Z equals to R square plus XL minus XC whole square. Then we are having a root. R is 10. 10 plus what is XL? It is LC. It is micro Henry only, right? So what is XL now? Omega times L is a 2 pi F times L. 2 pi by 3.14 into F. Is there any F? F is 50. L is 50 by pi 10 to power minus 3. Pi cancel out. It is 100. It is 500. No, 100. I will write here 100 once again. So look here, 2 into 50 it is 100. 100 into 50, 10 to power minus 3. So I can write 5000. It is 5, 10 to power 3 minus 3. It is cancelled out. So my answer is 5. XL is 5. It is 5 minus XC. And XC equals to 1 divided by omega times C. So I can write 1 divided by 2 pi F times C. XC equals to 1 divided by 2 pi. What is F? F is 50. What is C? C is 10 to power 3 divided by 5. 10 to power minus 6. Okay. Pi cancel out. It is 100. 100. It is 10 to power 2 plus 3 minus 6. 1 divided by. It will be 5. 5 minus 1. It is 10 only. It is 10 minus 10 whole square. Then root. So I can write it as a 10 plus 5 square root 100 into 25. So 125 root. So I can write it is 5 root 5. 5 root 5. Option number second, 5 root 5. My answer is 5 root 5. Easy or super easy? Easy or super easy? Okay, next one now. Next one now. Next numerical. This one now. Good numerical. Numerical state is that we are having a LCR circuit is connected to an AC voltage when L is removed. First condition is when L is removed. Inductor is removed. The phase difference between current and voltage is pi by 3. First condition, when L is removed. L is removed. L is removed. Phase difference is tan phi. Tan phi will be equal to XC divided by R only. So it becomes tan pi by 6. Pi by 6 is tan 60 degree. It is XC by R. Tan 60 is root 3. It is root 3 equals to XC by R. So it implies that XC is equal to R root 3 ohm. Okay. Second condition is instead of if instead C is removed, I will write C is removed. C is removed, so I can write tan phi. Tan, it is pi by 3, right? Pi by 3 means how much? 60 degree. It is XC divided by, no, it was XC, right? L is removed at XC, so it will be L. XL equals to R. So my XL is equals to under root 3 times R. Now look, XC and XL both are same, so this condition is resonance condition. Resonance condition. If this is a resonance condition, so my impedance Z is equals to R, and my cos phi is B by H. B is R, H is Z. So my cos phi is equals to R by R. So my cos phi is equals to 1 only. So phi equals to cos inverse 1. So when cos is 1, that is 0 degree. Okay, done. So but I had to find out power factor. No, yes, power factor is 1 only. This is my power factor. So power factor is 1 only. 1. Option number 3, power factor is 1 only. Okay, next numerical now. Next numerical now. This one done. This one now. Okay, what is the value of inductance L for which the current is maximum? So I need to my current to be maximum. For current maximum, my Z is equals to R. And 1 second. Okay, and my XC equals to XL, my VC equals to VL. Okay, and C equals to 10 microfarad, omega is 1000. So but it is currently needs to be maximum, that means omega equals to 1 divided by under root of LC. Done. So omega is 1000. I can write 1000 equals to 1 divided by L. We don't have any L value. L and C is how much? 10 to power minus 6, right? So it becomes 10 to power 1 2 3, then square 1 2 3, then 10 to power minus 6 multiplied by 10 equals to 1 divided by L. 6 cancel out, so L equals to 1 divided by 10, that is 0.1. 0.1 means how much? It is 100 millihenry. How? Look, it is 100. Milli is 10 to power minus 3, it is Henry. I will write there, look now, 10, 1, 10, so it is 10 to power 3, right? Cancel out, so we have 1 by 10. 1 by 10 is 0.1, so my answer is 100 millihenry. Samsul Rahman, beta ji, I will start the 11th. Okay, look, I haven't started 11th yet. Reason behind it, the main students of mine, they belong to 12th. Okay, so first of all, I want to complete the 12th. And I guess you can see the speed of my teaching and the content I am giving. From next month, that means from 15th September, I will start my 11th also. From next month onwards, I will start the 11th, and before December, I will complete my 11th also. From January, we will start revision classes of 11th as well as 12th. Okay, don't worry, if you have not studied any 11th class, there is no issue. From next month, I will study, I will just start 11th only. Okay, don't worry about anything. Next numerical. 1 second. Okay, so from this figure, what I need to get, we have to get out my power factor. What is power factor? It is cos phi. Cos phi. It will be R by Z. R is given to us now. R is 60. What is Z? What is that now? Sir, I guess Z equals to R square plus XL minus XC whole square than root. Yes, sir. So R is how much? It is 60 square plus XL. It is 100 minus 20. It is 80. 80 square root. Done. It will be 60, 36, 64. Then it is 100. It will be 100 now. Cancel out. It is 6 by it is 0.6. So cos phi equals to 0.6. My answer is 0.6. Okay. So look now, if you know the basics of any numerical, now. So look, you are getting these numericals done in within some seconds, right? But if you know the basics, look now, R, okay, what is power factor? Sir, it is cos phi. Okay, cos phi, we are having the angle, we are having a triangle, na? In triangle, bases are perpendicular XL minus XC and hypotenuse is Z. So what is cos phi? Cos phi R by Z. What is R? R is 60, Z is 100. How you will get 100? Because R equals Z equals to R square plus XL minus XC whole square ka root. So we got the value. So it is 60 by 100. It is 0.6. Done. Let us recap previous classes. Let us recap some of the points, right? Look, if we are dealing with pure R, in pure R, no lag. In pure R, no lag. If we are dealing with pure L, inductor, in inductor V leads by pi by 2. If you are dealing with pure capacitor, pure C, right, I leads by pi by 2. If you are dealing with RL circuit, RL, there is no component of R and L separately. These are mixed. So my angle will be less than 90 degree and more than 0 degree. Then if you are dealing with RC, in RC circuit, so same, phi is less than 90 degree and more than 0 degree. If you are discussing about LCR, but in LCR two components are there. If my XC is more than XL and if my XL is more than XC, if XC capacitor is more, that means current leads. If my XL, that means V leads or I lags. So this thing you need to keep in your mind. Very easy, super easy, critical easy. Okay. Next numerical now. Next numerical now. Next numerical now. Look now. We are having a LCR circuit. Okay, sir, connected across a E input, that is 10 sine 100 pi t minus pi by 6. Current from the supply. I is also current is given to us. What is the average power dissipated? Average power dissipated. Sir, what we have to find out? Average power dissipated. So we have to find out P average. What is P average? Is it VRMS? Then IRMS? Then cos phi. So what is this one? Equals to E naught sine omega t minus phi. What is this one? I equals to I naught sine omega t plus phi. Done? Or phi 1, phi 2. So what is VRMS? Is it V naught by root 2? IRMS is I naught by root 2. What is cos phi? What is cos phi? What is phi is given to us? Okay, pi by 6 is pi by 11. What is phi now? Phi equals to, I will write here, 100 pi t minus pi by 6 minus 100 pi t minus pi by 12. Cancel out. So is it minus pi by 6 minus pi by 12, which is minus pi by 3. And cos minus theta equals to plus cos theta. So I can write cos pi by 3. Right? It is cos pi by 3. It's not pi by 4. I write cos pi by 4. Pi by 4 means 1 by root 2. It is 1 by root 2 answer. So look, what is V naught? V naught is 10. I naught is 2 divided by, it is 2 into 1 by root 2. 2 to cancel out, my answer is 10 root 2, or I will just rationalize it. So my answer came out to be 5 root 2 only. My answer is 5 root 2. Easy or super easy? Easy or super easy? Easy? Okay, next point. Next point now. Then discuss now. This one now. A good numerical. Okay. So what we are having now, we are having a LCR circuit. What is the resonance frequency? So what we have to find out? A resonance frequency, either omega or F. Look, it is radian per second, so we have to find out omega only, not F. Done. So we have to find out omega. Omega equals to 1 divided by under root of LC. 1 divided by under root of, what is L? L is 8. It is 8 millihenry, 10 to the power minus 3. And C, what is C now? C is 20. It is 20, 10 to the power minus 6. It will be 8 to 16. It is 16, 10 to the power minus 3 minus 9 plus 1. It is minus 8. 1 divided by root, right? I will write here 1 divided by 4, 10 to the power minus 4. It is 1, 2, 3, 4 divided by 4. It will be equal to 2500. So this could be my answer, or this could be my answer, or this one now. So the amplitude means current at the resonant frequency. That simply indicates we have to find out VRMS equals to IRMS multiplied by Z. What is VRMS? 220. IRMS, it is I naught by root 2, and Z equals to 44. Why? A resonant condition, so Z equals to R. So my I naught is equals to 220 divided by 444 into root of 2. 2 ones are 2, 1, 2. So it will be 10 by 2. It is 5 root 2. 5 root 2, 5 root 2, 5 root 2. Okay, this one now. Option number A is correct now. Option number A is correct. Okay. Now I will just show you one particular point. Look now. If I am just telling you make a graph between frequency and resistance, you will make a straight line. Do you know why? Because there is no effect of frequency on the resistance part. But if we are talking about frequency and XL, we know that XL equals to 2 pi f into L. It is a directly proportional. It is this one graph. Third one now. If it is F and if it is XC. Okay. And we know that XC equals to 1 divided by omega C. That is 1 divided by 2 pi FC. It will be a rectangular hyperbola graph. But two more graphs from the NCERT. If we are talking about frequency and impedance Z, so your graph will looks like this now. At this particular point, it is frequency F naught, and you will have a minimum F now, that is resonant frequency. And if you want to make a graph of F with current, look now. Minimum value of Z, maximum value of current, I max. F naught means resonant frequency at which your opposition by the circuit will be minimum, current will be maximum. Reason behind the graph is like, look now. If we are having an circuit like, this is my circuit. If this is my circuit, look now. xc equals to 1 divided by omega times c, or 1 divided by 2 pi f times c. Okay, xl is 2 pi f times l. If my f is 0, if f is 0, so it is 1 divided by 0, that is infinite, and this one will be 0. That simply indicates, so this graph will look like this now. This graph will looks like this now. Open graph. So current is 0. Okay. Second condition, if f is infinite. So this equation will become now 1 by infinite, that is 0, and it infinite only. So this condition, now my equation will look like this now. Open, right? In both the cases, I equals to 0. Done, na? So now see this equation. When f is 0, when f is 0, when f is 0, here now 0, you have maximum infinite resistance. When f is maximum, your z is also maximum. This is a real reason behind it. Real reason behind it. Okay, this is a real reason behind it. Now let us discuss some more important numericals, then we can just wrap the class. This particular now, a coil of inductive reactance 31. Okay, inductive reactance, that means x of L is 31. Done. Okay, inductive reactance x and 31. Resistance is 8 ohm. So we are having LR circuit. It is placed in a series with a condenser, capacitor means, okay, of this much things. Combined connected to an AC of 110 volt, the power factor. So what is power factor? Cos phi. We are having what? Everything. It is R divided by Z. So I will write R divided by R square plus XL minus XC whole square power root. R is how much? It is 8 divided by, it is 8 square plus XL is 31 minus 25. It is 6 square root. 8 divided by 8, it is a 64, 36. 8 divided by 100 root. 8 divided by 10, 0.8. 0.8 is my answer. 0.8 is my answer. Okay. Okay. Now different. Next numerical. What is next numerical? Next numerical. The potential difference across the resistor, capacitor, and inductor is given this much. Power factor. Simply, now power factor. Cos phi. R by Z. Just multiplied with I divided by I. It will become I into R, Z into I. IR means V times R, it is V only. VR is how much? VR. 80. 80. What is V now? Is it V square divided by VL minus VC square root? Yes, sir. I can write 80 divided by 80 square plus VL. What is VL? It is 100. 100 minus 40 square root. 80 divided by 6400 plus 6036 root. 80 divided by 2, 4, 100, 0.8. 0.8 is my answer. Done? Easy or super easy? Easy or super easy? Huh? Easy or super easy? Easy or super easy? So I guess I have given you the best things, right? You need to now watch these things Which one better? Second setup. Which one now? Second setup. 1 second. Second setup. Okay, here, second one now. Second one. Okay, look now. Look now. We have the formula now. Look, look, cos phi equals to R by Z. So look, we don't have R now. Neither we have resistance nor we are having impedance. So if I just multiply I with the I, there is no issue. So we will get IR and we will get Z times I. What is IR? By Ohm's law, V equals to IR. We are talking resistance here, so it will become VR, potential across resistor. This is potential across LCR circuit. Done? So what is potential across LCR? It is V square plus VL minus V square whole square. VR is 80. So look, it is given as 80. 80. Then it is 80. Then all is mathematical calculation. I am showing now, beta. Do I need to just explain it once again? You can ask me now. There is no issue. If you want one more time the explanation, you can ask me. Thank you, beta. Thank you. Thank you. Okay. So now tomorrow will be the last class of AC. From Saturday or from Monday, we will start EM waves. Then, so thank you, beta. Bye. Good night. Take care. Bye. Thank you.